Hi everyone, this is Komal Singhal, and today in this slide we are going to discuss about the communication latency reduction using fog computing. So let's start with the introduction part first. When we talk about the IoT, so we came across that there is a large volume of data and information that is needed to be present. A lot of data is being generated from the IoT devices every minute. So what is IoT first? So IoT, uh, we call it the Internet of Things. It can be defined as a set of interconnected things which are generated via internet and which have the ability to measure, act and communicate all over the world. The main idea of IoT is to sense data from the environment, understand the data, process it and act on it. IoT makes our daily life easy. Consider a smart home where every appliance is connected to the internet. That means the device can be controlled from anywhere, like from your office, from your gym, even from other countries. So if we take an example, if suppose you are going home from office on a very hot day and want the room cool before you get into the room, if the AC would be connected to the internet, you can switch on the AC in the mid of your journey. As you reach in your home, it will be cool. So it's really a cool technology. So as we talk about Internet of Things, as already told that a lot of data is being generated. Sometimes by the time the data reaches the cloud server for analysis, the chance to act on it might be gone. Like the processing, analysis and storage of data should be done efficiently. There are some applications like we have healthcare services, vehicle networks that require very low latency. So to provide low latency, the services should be present near to the device. And the common applications of the IoT are smart home, as already discussed in example, vehicular networks, then video streaming, gaming, health services, smart cities, and many more. So the data handling tools for the IoT data are cloud, which is traditional, and now the one emerging technology which is coming is fog computing. So let's discuss that why fog and why not cloud. So we will take an example like let's start with this. There's when everything from cars and drones to video cameras and home appliances are transmitting enormous amounts of data from trillions of sensors, network traffic will grow exponentially. And when that happens, real-time services that require split-second response times or location awareness for accurate decision making will need to be deployed closer to the edge to be useful. Okay, think about it. Like if you're run a high-tech farm in anywhere in India, and it have sensor networks to monitor irrigation levels, soil moisture, ambient temperature, and so on. And you don't necessarily need instantaneous monitoring or on-premise server room. You'd probably be better off outsourcing that to cloud. So it is acceptable that if there is a delay in data processing, it is quite acceptable. But on the other hand, if you're driving down the freeway in your brand new car and a sensor determines that tire pressure is low or the brakes are about to fail, and you don't want to waste precious milliseconds sending data to the cloud and back when the car's own network is perfectly capable of communicating remedial measures. So luckily, processing power, memory speeds, and storage capacity on client devices are always increasing, and our bandwidths of cellular data, like we have 4G and 5G is coming. We have Wi-Fi, Bluetooth, and other network architectures that will enable distributed fog networks in enterprise data center around cities, in vehicles, in homes and neighborhoods, and even on our person via wearable devices and sensors. So let's go further into cloud computing and fog computing. Let's discuss their data communication channels. You can see here the devices, the end devices here, You can see the local access and Bluetooth, and then you can see the repeaters. There are number of repeaters before reaching the gateway. Then we have different number of gateways, and then we have cellular internet connection that will take it to the cloud. So it will take quite a large amount of time. It's a long process, it's a long journey, the data have to travel. But on the other hand, if you see that these are the IoT sensors, and then there are fog devices at the edge of the network. The processing, storage and analysis of data will happen here. So the processing and the latency will, latency time will decrease very, very fast. So let's move on to the other slide, in which we have covered the differences. The first one is about latency, which is quite high in cloud and low in fog. Then we have delay jitter, which is also high in cloud and very low in fog. So fog is very beneficial. The location of servers in cloud is within the internet, and in fog it's at the edge of the network. The distance between client and server in cloud, there are multiple hops, and in fog there is only one hop. When we talk about security, it's undefined in cloud, and when we talk about fog, it's defined. Location awareness, we don't have any location awareness in cloud, but in fog, yes, we do. Then the geographical distribution of cloud is centralized and the fog is distributed. So cloud provides limited support for mobility, but fog supports mobility. So these are the components of fog computing. You can see the picture. There is at the bottom there are IoT sensors and actuators. Then we have edge and cloud resources, which use machine to machine and software defined network SDNs. Then we have multi-tenant resource management, which has raw data management, monitoring and profiling. Then we have API and service management layer, in which API discovery, authentication and authorization processes are done. Then we have programming models, which are stream processing, sense, process, actuate, and there we have applications at the topmost. So after the benefits, let's talk a little about the identified challenges which are being identified in fog computing. The first one is it's difficult to enable real-time analytics. The second one is it's difficult to implement the programming models and architecture of fog computing. Then we have problems and issues with security, reliability and fault tolerance. And the other issue is of power consumption. The tools which can be used to implement or simulate fog computing are iFogSim, and the other one is the Cisco IOX platform. So at the end we can see that fog computing enables seamless integration of cloud and edge resources. It supports decentralized and intelligent processing. It helps the IoT to reach its vast potential. But there are some authentication and authorization issues, so a proper security framework is needed for safe computing. Thank you. Thanks for listening.